everyone, this video is on the exponential family of distributions, and I'm just going to go over how to identify if a distribution is part of the exponential family or not, and then hopefully later on there'll be more videos with examples. So first off, let us define our random variable y with PDF f of y with parameter theta. This distribution, it belongs to the exponential family if it can be written in the following forms. F of y theta is equal to s of y t of theta exp a of y b of theta. Just quick note, when I write this s of parentheses y or t parentheses theta, I'm considering this as a function of y or a function of theta. So this would be a single function of y, t of theta would be a single function, and a of y is a function of y, b of theta is a function of theta. Also, just a side note, exp to the a is equal to e to the a. It's just a shorthand a lot of statisticians use. So if your distribution can be written in this form, it's considered part of the exponential family. An alternative form, which in my experience is more common, would be exp times a to the y, b to the theta, plus c to the theta, plus d to the y. And just so you know, these distributions are related in that s of y is equal to exp d of y, and t of theta is equal to exp c of theta. These are not the only forms that show it's part of an exponential family of distributions. There is other forms. These are just the two that I'm the most familiar with and I'm going to go over. Some other helpful notes just to keep in mind about the exponential family of distributions is that b of theta, whatever this function of theta is often referred to as the natural parameter. Doesn't necessarily have to be theta, but it is what we would call the natural parameter. Also, if a of y is equal to y, then the distribution is considered canonical. This will be important later on. And then finally, if there is if theta is actually two values, for instance, a normal distribution has mu and sigma squared, we have two parameters, not just a single theta, then we'll just focus on a single parameter, and the other one would be considered a constant, often referred to the nuisance parameter. So you can still show that a distribution belongs to the exponential family of distributions, even if it has two parameters.